Okay, Computer Science A, Unit 9, Inheritance. This first lesson on inheritance, you're going to learn how to create a subclass of an existing class and understand that public methods are inherited by the subclass of a class and can be accessed from within the class by using keyword super. Inheritance in Java allows a class developer programmer to efficiently build one class from another. Rather than having to reinvent the wheel, a class developer can take advantage of the methods in one class and automatically include them in another class, plus add some more of his or her own methods. Now, to get a better idea of inheritance, let's look at a biological example of an inheritance hierarchy. So notice that organism is alive. An organism could be a I cannot pronounce these, which has one cell with no nucleus, and then a bacteria is of this type, and an archaea is an extreme. On the other side, we have plants and animals, and then note that animals can be an anthropod or a vertebrate, and then the vertebrate can be a reptile or a mammal. So notice things that a mammal is a vertebrate, which is an animal, which is a eukaryote, which is an organism. It is an is-a relationship going back up the chart. Each descendant type of organism inherits some attributes from its ancestor and adds some new attributes of its own. In nature, reproduction is only possible among members of the same species. Similarly, in an ideal object-oriented computer program, the only realizable or instantiable types are the types that are the very bottom of inheritance hierarchies. Ideally, all types above instantiable types are what we call abstract types. Now, it's important to note that abstract types, while it used to be part of the AP exam, it is no longer on the AP exam. Bottom of inheritance, we only make objects out of the bottom classes. Okay, so this, whoops, didn't mean to click that. So this example, hopefully you get an idea, but let's look at a couple of other more basic ones. Vehicles. We have automobiles and pulled vehicles. An automobile is a type of vehicle, and it could be a car or a bus, and these are motor driven. Okay. Over on the other side, we have pulled vehicles. It could be a cart or a rickshaw. A rickshaw is a pulled vehicle, which is a vehicle. A cart is a pulled vehicle, which is a vehicle. All vehicles have something in common in that they transport people or goods over some distance. Down here, let's look at some trees. A tree is a tree, but then it could be deciduous or evergreen. Evergreens could be spruce or pine. Pines could be red pine or white pine, while a spruce could be a blue spruce. And there may be other types of spruces. I'm sure there are. But if you get the idea, you're going from a most general to a most specific. The bottom of the hierarchy is more specific than the top. Now, inheritance in Java. The new class that is based upon the original class is called a child class, aka subclass or derived class. The original class is known as the parent or superclass or base class. For example, consider a person class for a person object. A person has an age, and that person's age, the default constructor sets that age at 0. And then you could have a constructor, a parameter constructor, where you create a person with a given age. And then a public, or not a public accessor, a public modifier, or a public accessor, sorry, does get the age. A public method have birthday will increase the age. And say something will say, I am a person. So this is a very basic person class. Now, if I want to build a student class, a student is a person, but a student also has a grade, has a property. They're in school. So they're at a particular point in school, and we call that a grade. It's like 9th, 10th, 11th, etc. But since a student is also a person, you want them to have the person properties too. So you can extend the person class in this way. Notice, public class student extends person. A student is a person, but then in addition to everything inside a person, a student has a grade. We need to give it its default constructor where the grade is initialized to 9. And then set grade if you want to set the grade to 10, 11, 12, something besides 9. You can get the grade, and then you can pass exams which would increment the grade. But the person also has an age. Now, if you want to build an AP student is a special kind of student, okay? In addition to having a grade and being promoted, if you will, they have an AP exam score property, as in a number between 1 and 5, as well as all the other properties of student. Then you can extend student. So public class AP student extends student. In addition to everything in student, an AP student also has an AP exam score. And we're going to let the default constructor create that as a 3. But then you can also set the AP exam score because they could get a 4, a 5, a 0, or not a 0, but a 1 or a 2. You want to get the AP exam score to examine it, okay? And if they study for their AP exam score, you would want to increment it from whatever it was at previously, as long as it's not at a 5, because you can't get a 6. Say something will output I am an AP student, okay? If you put in a string, return my AP exam score, and then you would output the exam score, okay? So there's a say something and a toString. But again, AP student is a student who is a person. So an AP student not only has an AP exam score, they have a grade and an age. Now, all methods in a parent class are inherited to its child class. So a student can call have birthday, get age, or set age, methods that are from the person class. A child class can have its own additional methods that are not inherited from its parent class. This allows the child class to have new behavior that the parent class did not need or that wasn't relevant to the parent class. Parent class, a person is not necessarily a student, so they don't have to have a grade. Okay? In the example, the child class student has pass exams method that its parent class person doesn't have. Because let's face it, not all people have to pass exams, not once they're done with school. All properties of a parent class are inherited by its child class. However, a client programmer cannot directly refer to any of the inherited properties in the parent class since they are usually private. Therefore, a client programmer must use the inherited public accessor and modifier methods to access or modify the inherited private properties. Okay, so you can't just go changing the age of a person if you're a student, but you can update it. You can have a birthday. You can access any of the modifier or accessor classes. A child class can have its own additional properties that are not inherited from its parent class. In our example, the child class student has a myGrade property. For example, 9th, 10th, etc., which its parent class person does not have. You should never redeclare the properties from a parent class in the child class. Doing that is called shadowing, and it leads to horrible logic errors, horrible logic errors. For example, if you typed private int my age in both person and student classes, then a student object would really have two my age values, and it would be very hard to tell them apart, besides the fact that there is no reason, and it is impossible for an individual student to have two ages. Now, notice the use of extends person on the first line of the student class. By doing this, you are allowing student objects in client programs to make use of any public method from the person class, since those methods are inherited. So the following lines of code would be valid in a client program. Student Jane is a new student. Student Jane.myAge is set to 15. This is an error. Remember that my age is private in the person class. So student Jane can't touch this. Now, student Jane dot set age 15, absolutely. Set age is a modifier within person, and it's public. So student Jane can change her age by using this modifier. Student Jane dot have birthday, absolutely. It's a public class. System.out.println student Jane.get age displays 16. Student Jane is a student. However, since student extends person, she has those attributes and can use those public methods that appear. So student Jane is instantiated. She has my age of 0, my grade of 9. This is what happens, okay, because the default constructor for person sets the age at 0. Default constructor for student sets my grade at 9. Down here, student.jane set my age of 15 will come along and would change this to 15. Then student.jane have birthday would change this again to be 16. And then here, this would output the 16. The say something method is overridden in the student class. Therefore, a student object, like student Jane, would behave differently from a person object when the say something method is executed. This is an example of polymorphism, since the say something method is used in multiple ways depending on the context and how it's being used. Consider this code segment from a client program. Person Bob is a new person. Student Jane is a new student. Person Bob.say something winds up displaying I am a person. However, student Jane.say something says I am a student. It's going to look first inside of student for this public method say something. If it doesn't find it in student, then it will go to person. Okay, this is kind of like having an animal. You could have a dog or a cat, and their say something would be meow or bark or woof. Okay, polymorphism. It runs the overridden method that makes sense, that's closest to it. Okay, since Jane is a student object, that is the method that runs. A child class can only be based on one parent class. So I can't have a student that extends a person as well as something else. They can only extend from one. Use the keyword extends to create a child class, as in public class checking account extends bank account. So the parent is a bank account. Checking account is a special type of bank account. Or public class fly extends bug. A fly is a particular type of bug. Again, you cannot extend more than one class. The relationship between a subclass as student and its superclass, such as person, is called an is-a relationship. That is, a student is a person. But you can't necessarily say that a person is a student. The is-a relationship is transitive. So if AP student is a subclass of student, and if student is a subclass of a person, then you can say that AP student object is a person. Okay? It only goes one way. AP student is a person. A person is not necessarily a student, nor is a student necessarily an AP student. A class diagram or hierarchy chart is a diagram where each class is represented with a rectangle and they are connected with arrows to show the is-a relationship between inherited classes. Parent classes are drawn at the top of the chart. AP student is a student. AP student is a person. Student is a person. Person is just person. They're not one of the others. A solid line with a hollow arrowhead is called is drawn from a child class to the parent class that it extends. This indicates an is-a relationship. Classes in the same level of a hierarchy are called sibling classes. So person, student is a person, college student is a person. Both student and college student extend person. They're on the same level, so student and college student are sibling classes. Now, usually you declare an object with the same data type that you use to instantiate the object, as in person Bob is set to new person, where the data type person is used on both sides of the statement, i.e. the left-hand declaration and the right-hand instantiation side. However, there are times in Java when you take advantage of inheritance to declare a reference for an object to its parent class, but instantiate it to its own class, as in person student Jane is a new student. Trust me to know that there are times when you want and need to do this, but the AP exam rarely includes questions where you need to know why this is done. You simply need to know how to trace the code that is explained in the examples below. You don't really need, at this point in time, to understand why you would do this. There's a lot in programming. It gets very complicated, and as you move through programming, you'll come to understand more and more why. Right now, just know that it can be done and what happens when it is. Now, doing this, declaring student Jane as a person, but instantiating her as a student, okay, prevents student Jane from executing any method that is not found in the person class. Even if the student class has a method such as study for exam, student Jane cannot execute study for exam since she's cloaked, i.e. referenced only as a person. However, casting can be used to uncloak student Jane and then allow her to call the study for exam. So I can let student Jane study, but only if we uncloak her or cast student Jane first. So I cast student Jane as a student, and then she can execute study for exam. Otherwise, the only valid methods she can call are those in person. Now, keep in mind that referencing or cloaking an object does not affect which version of an overridden method that executes. If both the person and the student classes have their own unique versions of say something method, and student Jane is referenced or cloaked as a person, she can therefore execute say something method since it is found in the person class. However, the student class version of the method is the one that executes. A little confusing there, huh? For the following examples, let's assume that AP student is a child class of student and that student is a subclass of person. So in this first example, person John is set to new student. John.have birthday is legal. Have birthday is in student. John.pass exams is not legal, okay? It causes an error because pass exams is in student, not in person. Therefore, if I want to say that John passes his exams, I must first uncloak or cast John as a student so that he can pass his exams. Person Sally is a new AP student. Okay, now Sally.have birthday, that's perfectly fine. Sally can only run methods in the person class unless she's cast to AP student. So Sally.study for exam, she can't do that unless we say that she's an AP student. Okay, so she's created, she's instantiated as an AP student, but declared only as a person. Example 3, we've got person 1 is a new person and person 2 is another new person. So how does this work? Well, person 1 is declared. Let's see here. Okay, so person 1 is created. and initialized with my age of 0. Then person 2 is declared and initialized with my age. But then when we do person 2 is set to person 1, remember that the memory location is what's here. So it breaks this connection and points person 2 to the same memory location that person 1 occupies. So now not only do they have the same value, they are pointing to the same memory location. Therefore, any changes made to person 1 are also made to person 2. Now, oh, and before I forget back here too, aliasing, the top hierarchy cannot equal the bottom. The bottom can equal the top. Okay? So the bottom can equal the top. So if I've got person 1 is a new person, student 1 is a new student. Person 1 is a top. I can't make person 1 point to student 1. Student 1 has more stuff in it, so I can't go that way. Okay? A top can't be set to the value of a bottom. Top hierarchy, bottom hierarchy. That's how creation. Bottom hierarchy cannot go this way. Right? Let's look at another example. Student, and this is what it means by you can't do this. Student Fred is set to new person. Student contains more than person. I can't make Fred a new person. I can make a person a new student, but I can't make a student a new person. Example 6, person 1 is set to new person. Student 1 is set to new student. Student 1 can be set to person 1. Okay? Remember, this has more stuff, so I can set it to something that's less. Think of it as having more, so therefore I can't take something more, put it into something less. It just doesn't work. These concepts can take some time to internalize. Using classes and inheritance when you develop your own code will help greatly to understand what is going on and how to effectively use inheritance. And make sure you work through any of the practice problems, practice worksheets, and use inheritance and extends in your code. Okay?